Welcome to the deep dive. Today, we're digging into something really fundamental in options, option delta.
Yep, delta, often called the most important Greek.
Right, and our mission today is simple. Break delta down, make it practical, make it easy to grasp, no jargon overload.
Exactly. So, at its core, delta, the symbol, it just measures how sensitive an options price is to the underlying stock moving.
Okay, sensitivity. So like if the stock moves $1.
Precisely. If the stock price changes by $1, delta tells you roughly how much the option price should change. Let's say delta is 0.50 or 50 cents.
Uh-huh.
Stock goes up a buck. The option, it should go up about 50 cents. Simple as that, really.
Got it. And there are limits, right? It's not just any number.
Absolutely. Key point here. For call options, the right to buy delta is always positive. It sits somewhere between 0 and +1.
Which makes sense. Stock goes up, the right to buy gets more valuable.
You got it. And for puts, the right to sell, it's the opposite. Delta is negative,
Yeah.
between 0 and -1.
Because if the stock price goes up, your right to sell at a certain price becomes less valuable.
Exactly. So it really just gauges that core directional exposure, up or down.
Okay, that's the definition. But how do traders actually use this number? That's where it gets practical.
Right. Two main ways, really. First, it's a hedge ratio. It tells you how many shares of the actual stock you'd need to buy or sell to kind of neutralize the option's directional risk.
Delta neutral, they call it. Offsetting small moves.
That's the one. The second use, maybe more intuitive for many, is thinking about exposure in terms of shares.
Equivalent shares.
Yeah. Since one standard U.S. equity option contract usually controls 100 shares of stock,
Right.
you just multiply the delta by 100. That gives you your approximate share exposure for that one contract.
Okay, let's make that concrete. Say an options delta is 0.556.
Okay.
So multiply by 100. That single option contract gives you the same sort of directional feel as owning about 55, 56 shares.
Spot on. Around 55.6 shares. And that's huge for figuring out how much risk you're actually taking on, position sizing.
And that number, that 55.6, it changes depending on the option, right?
Oh, absolutely. It depends heavily on moneyness, how close the option's strike price is to the current stock price.
So, like, deep in the money calls.
They act almost like owning the stock itself. They move nearly dollar for dollar, so their delta gets really close to +1.
And way out of the money calls. The long shots.
Yeah, those barely react to small stock price changes. They're unlikely to finish in the money anyway, so their delta, it drops down close to 0.
Okay, that intuitive feel makes sense. Now, there's this common shortcut I hear about.
Yes, the probability thing.
People say delta is basically the probability that the option will expire in the money. True.
Well, it's a very common rule of thumb, and it's close, but, and this is a really key point, it's not strictly accurate.
Okay, unpack that. Why isn't it exact?
Mathematically, delta isn't defined as that probability. It's actually slightly higher than the true risk-neutral probability of expiring in the money, especially when there's decent volatility or time left.
So if delta is 0.50, the actual probability might be slightly less than 50%.
Correct. Treat delta as a useful proxy, a guide for likelihood, but don't mistake it for the precise mathematical chance. It's about direction and magnitude first.
Good caveat. Always question the shortcuts. So in practice, traders talk about 25 delta puts or 70 delta calls. Why use delta like that?
It's a standardized way to pick strikes. A 25 delta option, whether it's a call or put, represents a certain level of out-of-the-moneyness and gives you about 25 shares worth of equivalent exposure per contract.
So it's consistent across different stocks and prices.
Exactly. It describes the option's characteristic regardless of the specific strike price number. And yeah, using that equivalent share exposure is fundamental for managing your overall portfolio risk.
Okay, delta helps manage directional risk. But options trading is complex. What does delta not tell us? Where can you still get hurt?
Great question. Delta is only about the linear part of the risk, the straight line response to price changes. It tells you nothing about the nonlinear risk.
Like what?
Primarily gamma. Gamma is the rate of change of delta itself. If gamma is high, your delta, your hedge ratio, is changing fast.
Meaning you have to keep adjusting your hedge constantly.
Constantly, which costs money. Delta hedging isn't static. And then there's Vega sensitivity to changes in implied volatility.
Right, volatility spikes or collapses.
And theta, the time decay, the value just bleeding away as time passes. Delta doesn't capture any of that. It's step one.
Okay, so let's wrap the core idea for you. Delta. It's your main gauge of directional risk.
Yep, tells you how much the option moves with the stock.
And it lets you think about your option position in terms of equivalent shares of stock. ranges from -1 to +1.
That's the essence of it. Simple but powerful.
But not the whole story.
Definitely not.
Yeah.
Which leads to a final thought to maybe mull over. We talked about delta hedging, trying to stay neutral. But to stay neutral, especially with high gamma, you have to constantly rebalance. Buy stock, buy options, sell options.
Which costs money every time. Commissions crossing the bid-ask spread.
Exactly. So if maintaining perfect neutrality requires constant trading and racks up transaction costs, especially in fast markets, how truly neutral or stable can a delta hedged position be in the real world? Is it a practical goal or more of a theoretical ideal you're constantly, expensively chasing?
Something to think about. The friction of reality versus the theory. Thanks for breaking delta down.
My pleasure. It's fundamental.